Oh, welcome to Free Maths Lessons, and today we're going to be looking at paper 3, higher tier. Okay, and these are paper 3 of the 2023 practice papers set 3. So these are designed for the May and June exams that you're going to be doing soon. Okay, so if you're setting the exams in May and June, then follow these. First questions: rearrange this formula to make C the subject. So we're looking to make C the subjects. What does that mean? If you're making C the subjects, means you're rearranging it so you get C by itself on one side of the equal sign, and it should be on top as well. You can't use it as a denominator. Okay, so first thing I would do here, if I were you, I would do is I'm gonna flip both sides around. So flip it around. Okay, so I would have 1 over A, and then which is equal to C over B. So now C is a numerator, and what's stopping us from having C by itself is that B. So multiply both sides by B. That will cancel off that B. When B divided by B gives you 1, so you're just left with that C, and multiplying this side by B as well. So on here we get B times 1, so that gives me B over A. Okay, we don't multiply B and A together because that's a numerator and A is denominator. And on the right hand side we have C. On the majority of the time you will have subjects on the left hand side. So if you want to, you can rewrite that as C equal to B over A. And that's your answer. That's it. Okay. Another way you could have done that is multiply both sides by C. Okay. So I got A equal to B over C. That's the second way of doing it. Multiply both sides by C. So we get AC equal to B. Now I want to get C by itself. So divide both sides by A. And you get C equal to B over A. That's another way of doing that same question. Question 2. Write 0.0078 in standard form. Standard form will always have this form: A multiplied by 10 to the power n, where your A has to be between 1 and 10. So it can be 1, but it cannot be 10. Okay, the first number can be 1, but it cannot be 10. So if I want to write the first number between 1 and 10, I have to have that number as 7.8. Okay, so decimal should be there. So once you know it's 7.8, how do I go from 7.8 to 0.0078? I need to divide that number here by 1000. Okay, I need to divide 7.8 by 1000 to actually write down your original number that we started with. So in other words, if you're dividing something by 1000, it's the same thing as this: 7.8 multiplied by 1 over 1000. Because again, if it's a standard form, I need to be writing that as multiplication by 10 to some power. Now 1 over 1000, we can write that as a 10 to the power 3. 1 over 10 to the power 3. So we can write that down as 7.8 times 10 to 1 over 10 cube. Now if it's a 1 over 10 cube, that's same thing as 7.8 times 10 to the power minus 3. Okay. Now I could have just gave you the answer straight away, and again you can get that from the mark scheme, but trying to remember it that way. Okay, you're gonna be dividing it by 1000 to get back to that place. It means 1 over 1000. Multiplying by 1 over 1000 means multiplying by 1 over 10 cube, and 1 over 10 cube is same as 10 to the power minus 3. Okay, so when you have negative power, it means you're dividing that number by 10 3 times before you get back to from there to your original number. Okay, so that's your answer. That's again the overlap. This question was in the foundation tier as well, and again you can use calculator, put it in the calculator, and if you have your calculator set as a standard form, then it will give you answer in standard form. But if not, just follow the method that we already looked at it in class. We got 7.68 multiplied by 10 to the power 9. Division means you can write it as a fraction. 3.2 multiplied by 10 to the power 4. So now if you multiply or divide the denominator and the numerator by the same number, then your fraction doesn't change. So what we're going to do is divide top and bottom by 10 to the power 4. So 10 to the power 4 divided by 10 to the power 4, that gives you 1. 10 to the power 9 divided by 10 to the power 4 will give you 10 to the power 5. So that's what you're left with over here. Okay, and I can do that as well. Divide top and bottom by 3.2. So then you do 7.68 divided by 3.2 and 3.2 divided by 3.2, you're left with 1. Okay, so let's say what do we get if I divide 7.68 by 3.2. And again, you are allowed to use calculator. We get 2.4. Okay. So at the top we get 2.4 multiplied by 10 to the power 5. And at the bottom you get 1 times 1, which is 1. So your answer becomes 2.4 multiplied by 10 to the power 5. That's it. That's 2 marks. So again, if you cancel the powers, probably get 1 mark. If you cancel the numbers, get 1 mark. Spinner lands on the red, blue or green. That's a relative frequency. The word relative frequency means a probability. If you're rolling it something 100 times, there are chances that you will land on the red 35 times, or you land on the blue 50 times and land on the green 15 times. So relative frequency means the probability that's related to the frequency. Okay. So how many more times did it land on red than green? But we're spinning it 400 times. So if I want to work out how many times it actually landed on each one of those colors, I need to multiply 400 by the probability. Okay, so that's the expected value as well, you can call it. Okay, so expected value of red, or the value how many times it landed on the red, was 400 times 0.35. Okay, and that would give me 140. So I can do 35 per 100. Okay, and then if I wanted to work out how many times it landed on the green, so I'm doing 400 multiplied by 0.15. That gives me 60. So the question is, how many times did it land on red more than the green? Okay, so we just take away that. 140 take away 60 gives me 80. So it landed on the red 80 more times than it landed on green. That's it. That's 2 marks for that. Front elevation means what does this shape looks like if you look at it from the front. Okay, so from the front, all I'll be able to see is that square, 4 by 4 square, and I'll be able to see that rectangle. I won't be able to see the top part unless someone showed me slightly that way. Then you can see the top part. If I don't show you what's hiding behind me right now, you won't be able to see anything past me. I know you can tell I'm a 3D person. I have a width as well because of how the light is reflecting off me. But generally, you won't be able to see anything past that if you keep it in the same level as the camera there. Okay, you don't know how many layers there are. All you see is 2 height, 2 and the 4 length. Okay, so 4 by 2 rectangle. So same thing, if you put that circle further away. So for example, that's a circular shape. Okay, that's a circular shape, but all you can see is a rectangle. Got the width there and the height there. You can't see it's a circle unless I tilt it slightly. Okay, you can't see things that's going wrong if you put this camera further back. All you see is a rectangle. The same way, you can't see the curved part. So all I see here is this 4 by 4 square from the front, and then 2 by 4 rectangle. So this represents your cylinder at the top, and that represents that if you look at it from that view. So if I have to draw it on centimeter by centimeter grid, I need to make sure that I'll draw that accurately. So 4 centimeter height, 4 centimeter width. And for the same thing for the cylinder, height was of the cylinder was 2 centimeter. So I need to make sure that's cylinder here, and that was your cube. Okay, that's all you had to do. Same part for 4b. So similar things, but this time you turn that cylinder sideways. Okay, so you can see circle from that side. If you look at it from that angle, you would be able to see this circle. But if you look at it from this point of view, it's like seeing this. Okay, all you see is a cuboid and the circle, rectangle on top. But if I look at it from the side, it's meant to be like this. If I look at it from the side, this is what I'll be able to see. Okay. There. A circle and the cuboid. So you see from the side here, this is what it looks like. But if you look at it from the front, I see a square and a rectangle. Obviously, that's not the way I wanted to show you that, but this was a lot smaller. So all you see is a rectangle and the square from the front. Okay. Right. So I can draw those as well quickly in 4x4 grid. Remember, same circle. The height of the circle is 4, and that width is 2. And that's exactly in the center, so you'll have 1 centimeter less that way, 1 centimeter less that way. Okay, so when I draw the front view, I will need to keep that in mind. Again, 4x4 square, that's 4x4 square, that represents cube. And then a 2x4 rectangle, this is your cylinder. Okay, and that's the front view, and that meant to be your side elevation, side view. So from the side again, I see 4x4, and this is your cube. And then from the side, what I see is this circle. Okay, you won't see how long that circle goes through. Okay, it's a cylinder circle. So from the side, I'll see that circle. Okay, they're going all the way around. So this is your cylinder. So that's your side elevation. In case if they ask you for the plan view, so what does it look like from the bird's eye view? And that is known as a plan. Okay, plan is just a bird's eye view. So from the top, all I'll be able to see is 4x4 square, and on top of that, you got something that's sitting on it, that circle thing. So you still see these lines, the edges basically, possibly. If it's a different color, then you can see that. So that's your cylinder, and that's the cuboid. So all you can see from the top is that. You don't see anything that's coming out of it. Okay, so that's your plan view. But that's not part of the question right now. Question 5. Our formula is s equal to 5t squared. We know s is the distance and t is the time. Ball is dropped and hits the floor after 1.2 seconds. So how high or how far does the ball travel in that 1.2 seconds? Okay, so what we're going to do is replace time with the t. So s is equal to 5 times 1.2 squared. And you put that in the calculator. Okay, 5 times 1.2 squared. And if I do that, I will get my answer 7.2. So that's the height of the meter, and 2 marks for that. Okay, but putting numbers in the calculator. Second part, if it's released from the 2 meters, so we know the s is 2, and we need to work out what the t is. Okay. So again, making t the subject. Okay, rearranging it for t. So trying to work out what t is. So divide both sides by 5. So 2/5. 5 divided by 5 is 1. So we get 2/5 is equal to t squared. If I want to get rid of the square, I need to square root both sides. So we're going to square root both sides. So on the right hand side, you'll get your t. And on the left hand side, you get plus and minus. Remember, when you square root a number, you always get two answers, positive and the negative. Okay, but it's a time. In this question, we're looking at to work out the time, and time cannot be negative for this one here. Okay, we can always have positive time here. So time going to be positive, so we look whatever the answer we get from square root of 2/5, we're going to use a positive number from that. And you put that in a calculator, you get 0.63 and more decimal places, okay? Or you can leave it as a positive square root of 2/5 because this is the accurate exact answer. Another common question that comes up in the both paper, foundation and higher, okay? So we're still looking at around grade 3, grade 4 questions. So distance going vertically up, so as you move along with the time, your distance is going up, okay? So for how long the toy car was stationary. Stationary means not moving, okay? So if I look at it from there, trying to look at the camera here, as soon as I start counting, I'm going to start moving my finger away from the camera, okay? So going 1, 2, 3, 4, 5, 6, 7, 8. So from 5 to 8, I did not move my finger at all, okay? That's being stationary. As the time goes on, distance doesn't change. So have a look at this one here. If you can't see the graph properly, that's the point there. So the line runs nicely up to that point, and at 4 seconds to 7 seconds, your distance remains 3 meters. That's the 3 meter away from wherever it started, okay? 4 to 7. So it was stationary for 3 seconds. Okay, didn't move for that 3 seconds, that flat line. Distance didn't go up, okay? And work out the average speed for the last 5 seconds of the journey. So in the last 5 seconds, we go from 3 meter to 10 meter. So we travel the distance in 5 seconds, 7 meter. Okay, distance divided by time will give you the speed, and that's what we're looking for, average speed. Okay, so the distance here is 7 meter divided by 5 seconds. Okay, and that will give you the speed 7 over 5 meter per second. Divide top and bottom by 5, you get seconds at the bottom, so 7 divided by 5 will give me 1.4 meter per second, and that would be the average speed. Question 7. Work out the show using algebra the rectangle and the T-shape have the same area. So we want to show that these two have exactly the same area. Work out the area of the rectangle, whatever the numbers are given to us. So we got been given the base as x plus 1. So we're multiplying 7 and x plus 1 together. Okay. So when you multiply that, we get answer 7x plus 7. So that's area. If you do that, something similar, 7 times x plus 1 and saying that's the area here, you will get 1 mark. Now work out the area of this one here. We do 2 times 2x plus 5. So 2 times 2x plus 5. And we can write that down as well. 2 times 2x will give you 4x. And 2 times 5 will give you 10. Again, if you need to, you can do these arrows as well. That helps you keep the record of everything that's happening. So we did 7 times x, which is 7x, and then 7 times 1, that gives you 7. So that's 4x plus 10. Obviously not the same. Okay? But we still need to add this part, which is 3 times x minus 1. 3 times x gives you 3x, and 3 times negative 1 will give you negative 3. We need to show that both areas are exactly the same. So I'm going to write it down. We're saying, okay, 7x plus 7 should be equal to that right hand side here. So just work with the right hand side here. On the right hand side, we go 4x plus 10 plus 3x minus 3. Okay, so that's what should be equal to that. So let's just collect the x terms together. So we got x, that's 4x, plus 3x, that gives you 7x. Thus x's are exactly the same. Now let's work with the numbers. 10 and negative 3 gives you positive 7. So 7x plus 7 is exactly same as 7x plus 7. So we actually show.
Right, okay, so for this question, what we're looking at is saying, okay, we need to place the wind turbine in a way so it needs to be closer to y, closer to this point here, than the x. But it also needs to be within the 12 kilometer radius from x, okay? So within the 12 kilometer, it could be here, but it has to be within the 12 kilometer distance, okay? So what we need to do, we need to label the region where can we actually place the wind turbine on here, okay? So needs to be closer to y than x, but within the 12 kilometer radius, okay? So first thing we're going to do is we're going to mark the 12 kilometer radius from x. Now we know that 1 centimeter represents 2 kilometer. So we're going to use a ruler and open our compass. So it's 6 centimeter wide. Okay. So we're going to open our compass, so it's 6 centimeter wide. So that's from 0 all the way to 6 there. And then you place it on the x and draw an arc. So we know our wind turbine has to be within this. Oopsie. Our wind turbine has to be within this circle. Okay. So I've done 6 centimeter arc from the x. So it has to be within this line. But now again, it needs to be closer to closer to y than x. So it needs to be on this side here. But how do we decide where that? I can't just draw randomly line here. This point here or this point here not going to be closer to y compared to this one. This one is closer to x than y. So I need to make sure that I draw the perpendicular bisector. Means I need to cut this x and y exactly in the half. Okay, so we can know where exactly both x and y are going to be exactly the same distance away on which line. To do that, I can look at it, the distance from x to y, and open your compass so it's more than halfway line. Okay, so similar to the last paper, more than halfway line, that is more than halfway line. So I'm going to draw the arc above the those two things and arc below those two things. And I kept it exactly the same as 6 centimeter anyway, so you can get that crossing point there and the crossing point at the top, sorry. There. So now where those two crossing points are, they are exactly same distance away from x and y, which is in this case 6 centimeter. We didn't have to keep it 6 centimeter, but it would just makes it easier for us to draw that. And then all we have to do is place your ruler on those two crossing points and join them up. So now that's line going to be exactly any points on those two that line here is going to be exactly same distance from x and same distance from y. So if our points needs to be closer to y, our points needs to be, or the turbine needs to be closer to y than x, but it has to be within the 12 kilometer radius. So that is our 12 kilometer radius. So it has to be within that, and it needs to be towards x. So you're saying shade the region and label it R. Okay, so we're gonna shade that region here. So you can place this wind turbine anywhere on this. That is your region R. So as long as you place the turbine on this part here, the shaded part is going to be close to y, then x, and it's going to be within the 12 kilometer radius. So this radius here is 12 kilometer. and that's 4 max.
Right, okay. Which class interval contains the median? So here's a frequency table that time taken to solve a puzzle. So that's 0 to 1 minutes for 38 puzzle. We solve that within 60 seconds. Within 2 minutes, 16 puzzles that has been solved between 1 and 2 minutes. 2 to 3, 17, 15, 14, and so on. Okay, the median one would be the middle number. If you could look at the cumulative frequency, where would the middle number going to be if you put those in? So these 38 would be very start. You get 38, you took less than 1 minute, and then the next 16, then the next 17, then the 15, then that 14. So those 14 and 38 weren't going to be median. So median class going to be somewhere in the middle. So if you solve 100 puzzles and you put those times, puzzle, it took you whatever the time it took you, you put those time in order, okay? So these first 38 puzzles going to be the first 38 numbers. You could have taken 1 second to solve some puzzles, or 59 seconds, or 58 seconds, or 30 seconds, whatever that is, that's going to be in first 38 puzzles there, okay? So we're gonna saying, okay, first 38 is going to be 0 to 1. Then the next one, next 16. So everything less than 2 minutes, you can add that 16 on, and that will tell you what that next 16 is going to be. If I add that 16 on, that will take me to 54 puzzles, and so on. So we already know which one's going to be my middle number. If I have 100 things, the middle number is going to be 50th and 51st. Okay, so 50th and 51st are those puzzles would have taken 1 to 2 minutes to solve that. So this is my median class here, 1 to 2 median class. So which class interval contains median? This one here. So my middle number, 50th number and 51st number going to be in this class here. Okay, so I don't need to really add other ones, but that's what you're looking to do. Electrician charges an hourly rate to fixed charge job. Okay, this is a repeat question. That question did come up in the foundation paper as well. So we're looking at saying 4-hour job, he charges 185. Since you're doing a higher tier, you should be able to solve this using simultaneous equation. So we're going to call X is your hourly rate. And then we're going to replace Y with the fixed charge. Okay, so first one, we do 4-hour jobs and earn 185. So 4-hour jobs mean you do have to work for every hour you're charging X amount of money. So we get 4-hour job, they get 4 times X amount of money. Okay, so they get paid for X amount of money. Plus, we need to pay that person Y, which is fixed charge, call out charge in other words. Okay, so they can get £10 and then charge £50 for call out. But we know that's not going to be the case because we know we have to pay them £185. The second time we call that person or someone else calls that person and they spend 6 hours doing the job, obviously spend 2 more hours working with it, so they would earn 6 times the amount of the hour they work. So 6 times X, the hourly rate multiplied by 6, plus the call out charge, in other words we call it fixed charge, and they would earn 265. So what we got is 2 equation, simultaneous equation. We can solve those simultaneously, means together. Okay, so those one I can see there's a Y that's common in both of them, so I can get rid of them by doing equation 2 take away equation 1. So difference between them is 2x. Y take away Y gives you 0. So in that 2 hour, how much more do they get paid? They get paid £80 more for that 2 hour extra work. So we can work out straight away what the hourly rate going to be. Hourly rate going to be 40. 2 hours have to pay 80, so 1 hour you pay 40. Now we can work out fixed charge by putting that hourly rate in here. So if they worked 4 hours, they would have made £160 plus the Y, that gets you 185. Okay, so 160 add y gives you 185. So y has to be 25 pounds. So 25 pound has to be the fixed charge for them to make 185 pound from the 4-hour one. Obviously, I don't need to write x and y here. It's saying hourly rate is 40, fixed charge is 25. You can check your answers by putting these numbers in here. If someone worked 6 hours, would they make 265? Yes. 6 times 4 gives you 240. Add 25 gives you 265. Two shapes are similar. Now, if two shapes are similar means they have the same angle within those shapes, okay? And every single length has to be multiplied or doubled, whatever the scale factor we're using. So enlargement, one shape is enlargement of the other. So every single length is going to be multiplied by the same scale factor. So once I know the height is going from 8 to 12. So how do I go from 8 to 12? Okay. Why am I multiplying 8 by to get to 12? Again, you're using calculators, you can do that very quickly. Do 12 divided by 8 and you can work out. So my scale factor is going to be 1.5. So I'm going to multiply 8 by 1.5 to get to 12. So every single length on here has to be multiplied by 1.5 to get the length on the other shape. So we're going to do the same thing here. Multiply 6 by 1.5 and you get the x, which gives you 9 centimeter. All right, this is the tank, okay, and the tank has a height 80 centimeter. So that's that height. Okay. And we don't know what the length and what the width is, but it's a tank. We're turning the tap on and it flows at a constant rate. Means continually. There is no pressure change, okay? There's no one else in the house that turning the tap on so the pressure in the tap upstairs will drop. No, that's not the case. It's going at the constant rate, okay? And tank is full after 50 minutes. And someone draws the sketch, Sita draws the sketch here to show the depth of the water during that 15 minutes, okay? So what happens to the depth means, okay, it's slowly going away. So it's got the curved graph basically, okay? So it starts filling up quickly and then slows down, basically, okay? That's what's happening to the depth of the water tank. Make two criticism of this graph, okay? If the water is flowing at constant rate and we got the container that's cubic, so it should be filling up at exactly the same rate. It shouldn't be doing faster to start with and then slowing down. So it should be a straight line graph. Because it's a constant rate, okay? Also, you can use the word linear. It should be linear graph. Straight line means linear, okay? And then secondly, there are no units on this vertical axis. So we don't know what that depth is going to be for each one of them. You can put them on. So that's a criticism anyway. Now, she probably know what those units are, but no one else knows, okay? So that's a criticism. No units on vertical axis or depth. So 1 mark for the first criticism and 1 mark for the second criticism. Again, you don't have to write paragraphs about it. Right. We're looking to draw a box and whiskers plot using this information here. The lowest value, highest value, lower quartile, upper quartile, and median. So we can draw a box with these three. And those two, lowest value and the highest value, are your whiskers, okay? So again, you can use the middle layer as doing your box plot. So I'm going to draw the lines where the lower quartile is. So lower quartile is first 25% of the values. So 26. So it's going to be 3 places away from there. So it's going to be that. Okay. And then we do the lines at 52. And then we're going to do line at 72. Every small box in this is 2. So that we draw the box around that. Okay. Try and draw accurately and use ruler and pencil. So if you go wrong, you can sketch it, rub it up and draw a new one. I don't have that option right now, so that's why I'm doing it, okay, without ruler. And then we do the whiskers which is at 14 and 82. And you need to join them up with the straight line like this. And that's why it's called box and whiskers plot. So these two are whiskers, the lowest value and the highest value. It should get you that 2 marks. Now another one where the median is 57, higher median. Okay. For the another, here's some information about time taken in minutes for the children. For the adult children, median is higher. Okay. So that means children, on average, children took longer to complete the task. That's what it means. Okay. And the interquartile range is 41, whereas the interquartile range means difference between the quartile here for the adult is 72, take away 26. What would we get? 46. So the interquartile range between the adult was 46, whereas the interquartile range between the children is 41. So who was more consistent in the time taken to complete the challenge? So interquartile range always tells you about the consistency. Okay, so if someone's range is smaller, that means they all taken that time within that space. The box would be a lot smaller for them, not a lot smaller, but 41 compared to this 46. Okay, so children's were more consistent. Why? Because their interquartile range was smaller. Okay, so adult, so I'll write it down as saying IQR for adult, interquartile range for adult was 46, whereas the interquartile range for children is 41. So the lower range means more consistent, okay, and therefore the children were more consistent. So that's all I needed to say to actually show my working out, okay. And you wouldn't get marked by ticking adult or children. You need to show some sort of working out. Even though I did that working out over here, but that's not clear. I needed to write it down somewhere here. Right, okay, so we got three, and it picks 3 digits odd number, 1, 2, and 3 digits odd number. Now the first digits has to be, so we know the last digits you can have 5 different choices. Okay, you could have 1, you could have 3, you could have 5, you could have 7, you could have 9. So we go for the last digits, we have 5 different choices. Okay, it could be any of those 5 numbers. Then the first digit is less than 4. So if the first digit is less than 4, then we can have 3 choices for the first digits, 1, 2, or 3. Okay, you can have any of those 3 choices. And then the second digit is greater than 5. So if his second digit is greater than 5, that means it could be anything from 6, 7, 8, 9. So 4 choices for that. So if I multiply them together, I can work out how many different numbers I can make from here. I could use anything from 1, 2, or 3 and match it up with these 4 numbers and 5 numbers. So we have 3 times 4 times 5 choices, which gives me 12 times 5, which is 60 different choices. Alright, okay, so here's a question here saying we got the pack of rice and Gada's daily allowance is 2000 calories. So 2000 calories he is allowed to take. Okay, I was doing it slightly smaller there. So Gada is allowed to take 2000 calories. So one serving is more than 5% of my daily allowance. Okay, so let's say, what is the 5% of our daily allowance? Daily allowance is 2000. What is 5% of 2000? So we're going to do multiply 2000 by 0.05. That's the 5% of her daily allowance. So the 10% would be 200. So the 5% would be 100 calories. She is allowed 100 calories. Okay. Now that's the first fact. Okay. Then next thing here, saying one serving is more than 5%. So let's say how many calories are there in one serving? So we go 490 grams and that serves 7. So sorry, that's the 7 serving. So let's say first work out how many grams do I need in one serving. Okay, so we're doing 490 divided by 7. That tells me how many grams there are in one serving. Okay, so 490 divided by 7, that gives you 70 grams. So there are 70 grams in one serving. So that would possibly get you 1 mark. That would possibly get you 1 mark. Now we need to work out how many calories are there in 70 grams. So in the 100 grams rice, we have 130 calories. So we're going to write that down here. 100 grams represents 130 calories. Okay, so we need to go from 100 grams to 70 grams. You can go straight from 100 to 70, okay? Or you can go to 1 gram and then go to 70 grams. So I'm dividing it by 100 and then multiplying by 70. Okay. Dividing it by 100 and then multiplying it by 70. So you're basically trying to work out how many calories there are in 1 gram, divide that side by 100, divide that side by 100. So in 1 gram we have 1.3 calories. Okay, and then multiply both sides by 100. Sorry, multiply both sides by 70. So if you 1 gram has 1.3 grams, 1.3 calories. So in 70 gram would be 1.3 times 70. 1.3 times 70 will give you 91. So in one serving of this, they have 91 calories. Is that more than 100 calories? No. So we can tick no, and we just shown you working out saying 91 is less than 100, which is 5% of her daily allowance. Write this in that form. So again, it's a completing square. Okay, so we're going to try and write this in that form. So we're trying to complete the square and it'll give you 2 marks. Okay. So completing square with x squared, you would have this. That's x by x. And that gives you that x squared. Again, I want to keep it square. And if I have 10 x's, think about it as just a strips basically. X by 1. That's 1 and the height is 1. So how many strips do I need to put there and there? Obviously, if I want to keep a square, I need to keep same number of strips there, same number of strips there as well. So that should be 5 there and 5 here. Sorry, that's not 5. They don't look the same. But I'm going to try and make it same now. So that's 5 there and 5 here. Okay. So 5 and 5 there, okay? So that's 5 x's there, 5, length 5, length 5. So I know the square is going to be x plus 5 by x plus 5. Now I probably have some leftover things, probably have some short of the things. Now I go 28 there, okay? So I will get 25 here, that's small cubes, 1 by 1, okay? These 1 by 1 small squares, 25 of them here. So I've got the completed square version already, and then I need 3 more. So I need 3 more, so those 3 more is going to go here. Okay, so that's my completed square. I can do this. If I have the square, that's x plus 5, all squared. That gives me x squared, 10 x's, and 25. I need 3 more, so I need to put that 3 on. Okay, so my completed square form from there to there goes there. Okay, and this is what I use. Obviously, I'm going to go through one lesson that will explain how to use these algebra tiles to understand the quadratics a lot easier, okay, or understand it better. But that's what we get. Half the 10, which is 5, close the bracket and square it. Take away the square of this number here, which is take away 25. Why? Because of this 25, which gives you that 3 left over. Okay, that's straightforward. Okay. If people are using just a method, then I will do that as well. We do x plus half of that number, which is 5, square it and take away the square of this number, which is 25. and then add that number that we already have, which is 28. 20, negative 25, positive 28 gives you 3. And that's, we already got that A and B is. 16b. Hence write down the coordinates of the turning point of that curve. Saying, so if you're saying where does it turn? So the turning point is a positive quadratic expression. So we'll have that graph. Okay. So where does it turn? That turn means where does the y value, this is the y-axis. Okay, where is the y value at lowest? So we already wrote it down as this, saying x is going to be x plus 5 all squared, x plus 5 all squared plus 3. So if you have any square number, could that ever be negative? No, square number will never be ever be negative. Okay, the smallest you can get is 0, the square number. So the lowest value I can get for y, because this is y equal to, lowest value I can get for y value is when x is minus 5, and that would give you that 3 as a 0. So x has to be minus 5, and the lowest value I can get from here when x is minus 5 and y is 3. Okay, so that's what that turning point is. So when x is negative 5, I get 0. From 0 square is 0, and then plus 3 gives you 3. Y value would be 3, and that's the lowest one you can get. A, B, and C are positive integers. A to B is 7 to 9, and B to C is 12 to 5. Work out the smallest possible value of A plus B plus C. So, right, so we can say that A to B is 7 to 9 and B to C is 12 to 5. Okay, and we need to work out the smallest possible value for A, B, and C. So first thing I need to do is work out the lowest common multiple of 9 and 12. Okay, so lowest common multiple of 9 and 12. So I can do the same thing and I get the same number for the B. And that will help me decide what's my C going to be if I keep all of them in the same direction, basically. Okay, so the lowest number I can get here for those 9 and 12 is 36. Okay, because 12 times 3 is 36, 9 times 4 is 36. So both number will go into 36. So for this one, first ratio, I multiply 9 by 4. That means I need to multiply A by 4 as well. So that will keep something to 36. Okay, so 8 times 4, so that gives me 28 to 36. That's perfectly fine. And I multiply this 12, so second one 12 by 3 to get to 36. I need to multiply that by 3 as well. So 5 times 3 will give me 15. So that's the ratio we should have. 28 for A, 36 for B, and 15 for C. So if I wanted to write down the smallest possible value, there shouldn't be anything common between them. There isn't, and if there is, you can simplify it. So smallest possible value for this is going to be 28 plus 36 plus 15. 79. When you add them all up, that gives you 79. Proof question is always difficult, okay? So, and it's 3 marks. So if you can't do anything, do something and do that record, keep that record, okay? If you're trying to prove something, I'm going to write down saying, okay, that's always going to be negative, and you got 2 brackets there. Can you multiply those 2 brackets? Start doing that. Multiply those brackets out. Even if you don't get to the answer, you will get 1 mark at least, okay? So do that. Multiplying these brackets out, okay? 2n times n, 2n squared. 2n times 1 gives you positive 2n. And then you got 3 times n, that gives you positive 3n. And then 3 times 1, that gives me positive 3. Now again, that possibly get you 1 mark. So now what I'm going to do is I'm going to remove the bracket. So you got to multiply everything by this minus sign. Okay, so we would get is 5n minus 2n squared, then minus 5n, and then minus 3. Okay, So we get 5n and negative 5n will cancel each other out. Okay, that will give you 0. So this positive 5n and negative 5n will give you 0. So what you're left with is negative 2n squared and then negative 3. So we already proved it. That's always going to be negative regardless of what that number is. We're going to have the negative answer, because if n squared, that n doesn't matter. If n is positive, then it's going to be positive number. Okay. If n is negative, it's going to be negative number. So if n is positive or negative, the n squared always positive. So square number always positive. Positive number multiplied by negative number will give you negative. So that's going to be negative 2 times something. Doesn't matter. And that's going to be negative 3. And if you add two negative numbers, answer always going to remain negative. So that just proves it. 3 marks for that. Nothing more than this. N squared is always going to be greater than or equal to 0. That means negative 2n squared is always going to be less than or equal to 0. And that means you will have overall, smallest number you can get is biggest number you can get is negative 3. Nothing more bigger than negative 3. To work out the approximation to the solution, this. Okay, so start with x equal to 1, and this is all calculator work. Okay, so we're going to put 1 and press equal. I'm going to try to talk close to the mic here and try to work through that. Okay, so we're doing 1 and press equal. Now what we're going to do is we're going to do the square root, then you do 2. I'm going to try to use brackets, sorry. Okay, I have to start again. 1 equal. So 1 is now saved as an answer in your calculator. Then we're going to do square root. I'm going to put the brackets, so we're taking the square root of everything. I'm going to do another bracket in case we miss anything out. So go 2, then the answer, plus 4, close one of the brackets, divide by 5, close another bracket, press equal. So we get 1.09 when you put that value. Okay, so we get x2 is equal to 1.095445. So when you put that in the calculator, you get x equal to 1.095. We need it to 2 decimal places, so I could just get away with writing it 3 decimal places. Okay, and then you keep pressing equal. Keep that same thing. Press equal. Now the answer, wherever the answer is, this number will replace the answers. Okay, you get 1.1127. So that was our x2. x3 is 1.1127. Press it again. Then x4 is equal to 1.1158. And I keep pressing it, and if the numbers doesn't change, the first 2 decimal place doesn't change, then you can write it down. At the first 2 decimal places, it would be x, whatever that is, which is going to be 1.1165. So we can round it to 2 decimal place as a 1.12 if you wanted to, but you can leave it as 1.11, and that's your answer. Okay, it's called iteration. So you always use calculator. Press x equal to 1 and equal sign in your calculator. Then put that in, but instead of xn, we're going to put answer. There's an answer button in every calculator. You use that answer button in the calculator, okay? And put it in, because that answer is stored as 1 right now. Make sure you use enough brackets so you don't make any mistakes. And then just keep pressing equal sign until the first 2 decimal places stabilize. Okay, and then you can write your answer down after that. Okay? saying this 1165, that's always going to remain there, so we can round it to 1.12. Find my question. Work out the height h of the tower, and that's 90 degrees. We can work out what that angle is as well. So that's 90 degrees, that's 39. So this angle here is going to be, that's 51 degrees. We know that angle is going to be 51, and this angle here is, because that's 31, and this angle here, or you can look at it as the big entire thing. Okay, that's 31, that's 51, that's 82, that's 90. So this angle here is 8 degrees. Okay, it's up to you how you want to work out, but that will turn out to be 8 degrees. Using the sine rule, we can work out this length, and once you have that length, you can work out the height. Okay, so we're going to use sine rule, which means you can do the length here that's given to us, AB, 25, over the angle opposite that, which is sine of 8 degrees. That should be equal to BD, that length there, B to D, over the angle that's opposite to this length, which is that one here, 31, sine of 31 degrees. Okay. And you rearrange it, so multiply both sides by sine 31, so we get 25 multiplied by sine 31 divide by sine of 8 degrees, that gives you length BD. So we just need to put that in the calculator, and that will give you the length BD. So the length BD is 92.5 at 1 decimal places. Obviously you can continue with it, but that's at 1 decimal place is 92.5. Now we know the hypotenuse, we know the angle, and we need to work out the opposite. So just looking at focusing on this triangle here, we're using a SOHCAHTOA. Okay, so we know we need to work out the opposite, we know the hypotenuse, and it's a right angle triangle. Okay, so we're gonna do, so we know the opposite, work out opposite, and we need to work, we know the hypotenuse, and we need to work out the opposite. Okay, so we say sine 39 is equal to opposite, that's what we're trying to work out, that h, over hypotenuse, which is 92.5. Okay, so multiply sine 39 by 92.5, you work out what your opposite, which is that h, is going to be. Multiply both sides by 92.5, and you get that opposite, or the h, is equal to 58.2 or 3, one of those, depending on where you round it numbers to. So 58.2 some decimal places, and that will get you that final marks there. So lorry can carry maximum of 15,000 kilograms at 2 significant figures. So we're looking at the problem where you're looking for lower bound or upper bound here. Okay, so let's just look at it as a lower bound, upper bound at 2 significant figure. So that's your second significant figure, and 15,000 kilograms. That's the second significant figure. So at 2 significant figure, we're looking for the neighbor. What's the next number going to be on the other side? So it would be the 60,000, and then you can have 14,000. Obviously these are your neighbors. Competition, we're not looking for boundary. Boundaries are all the number that rounds to 15,000, so it's a halfway between there. So anything from 14,500 rounds to 15,000, so that's your lower bound, and anything below 15,500 rounds to 15,000, that's your upper bound. So if your maximum limit is 14,500, what would happen basically? By 14,500, and you carry 28 or 2,800 kilogram at 2 significant figure. So again, we can work out the lower bound and upper bound for that. So we're going to try to work out exactly the same way. 8 is your second significant figure. So the next number here is going to be 2,900. And then the number before that going to be 2,700. So the lower bound is 2,750, and then the upper bound is 2,850. 50. So these are your lower bound and upper bound for this. So we're saying this, the lorry could be carrying 20% of its maximum load. Okay, so 20% of its maximum load. Okay, so let's say the lorry should carrying 14,500. So what is 20% of 14,500? So we multiply 14,500 by 0.2, and that'll give you 20% of 14,500. So 2,900. So lorry could be carrying 2,900, up to 2,900, which is 20% is 2,900. So even if you're looking at the upper bound of the container, that's still not going to be close to 2,900. So we have to say no, okay, or take the no, and you show the working out, because the 20% of 14,500, so 20% of the lower bound is 2,900, which is a lot less than lower bound or upper bound of container. So the maximum weight the container could have had was 2,850. So that's the maximum weight. So 2,900 is lower than 2,850. Therefore, the statement is wrong. Bag contained 20 sweets, 12 green, 5 orange, and 3 blacks. 2 sweets are taken from the bag at random without replacement. So you're not replacing it. Okay. Work out the probability of picking only 1 orange sweet. Okay. So there are different probability at every stage. Okay, so we're picking 2 sweets at random. So we can do probability tree diagram very quickly. And there are 3 different colors. So we can say, okay, start with the green, orange, and black in the first peak. So it's 12 out of 20, 5 20th, and 3 20th. Okay. And now the second pick, you will have this. And again, it's without replacement, so we're not putting it back in there. So now we'll have 11 green out of 19. And then you'll have 5 orange out of 19. And then you'll have 3 blue out of 19. So the green, orange, and blue. Okay. So you get the idea. When you do that, the probability of picking 1 orange would be this multiplied by these 3 branches there. Okay. Or that multiplied by probability of 1 orange there. Probability of 1 orange there multiplied by that. So there are 3 different ways you could have got that. So work out the probability of picking only 1 orange sweet. So we could pick 1 orange sweet by doing green in the first go, which is 12 out of 20, and multiply by orange in the second go, 5 out of 19. So that's one way of picking 1 orange sweet. Okay. Then you go on to this one. We can pick the 1 orange sweet. If you do orange in the first go, which is 5 out of 20, multiply by the green, which is again in the second go, which would be 12 out of 19. Okay. Plus, you can have the the first 5 20th multiplied by the black in the second go, which would have been 3 out of 19. Or you can pick the black one first, which is 3 20th, multiplied by the orange, which you already should have 5 left over, which is 5 out of 19. So when you add those numbers up, that will give you the probability of picking only 1 orange from that without replacement. Obviously, if I had more space, I would have completed that tree diagram. Okay, so that's what you would get. So we get 60 over 380 plus that one, again 60 over 380 plus this one, 15 over 380 plus that one, which is also 15 over 380. So altogether we get 180, 60 plus 60 plus 30, not 180, 150, sorry. 150 over 380. So probability of picking orange one is 15 out of 38. By drawing the tangent to the curve, work out the rate at which the tire pressure is increasing after 1 minute. Okay, so at 1 minute, which is that line there. So we're going to try and draw the tangent at that point. Means they're touching the curve exactly at one point. And what would that be? Okay, so you're trying to draw the tangent, and it probably look something like that. Okay, yeah. So we can say that at 20, okay, and that would be somewhere between 0.7. So trying to draw that thing. So once I've done the tangent and try look at the thing, so in a half a minute, I'm going up 6 places here. It's not going to be accurate, okay? So I'm trying as best as possible to try and make this whole numbers and the easier number to work with as possible, okay? So that's 0.5, and when you move 0.5 seconds across or minutes across, pressure is going up by 6, because going from 25 to 26. Every 2 boxes here is 1. So the gradient, that's the rate of change. So 6 divided by 0.5. That's your gradient, that's the rate. So 6 divided by 0.5 will give me 12. So that's going to be 12 psi, 12 pound per square inch. Psi, that's why unit for pressure is pounds per square inch. Imperial units, no wonder. So does tell you, give your unit of your answer. So it's 12 psi. 12 pound per square inch. Describe single transformation of a triangle for which all points A and B are invariant. There are no other invariant points. Okay, so invariant means the points that's not changing. So this line shouldn't change when you do the transformation. Invariant means not changing, it's not varying. Okay, so what kind of transformation that wouldn't change this A to B line? If you reflect the shape, this triangle in that line, A to B. So we're going to say that reflect this triangle here, ABC, in the line, this line here. What is the equation of that line? Is going through where the x is equal to 1. Any points on that line, x value is going to be 1. So in the line, x equal to 1. That's it. But you need to say everything. This is IITA paper. You should be able to do that. Next one, here's the L shape, PQRSTU. Describe fully a single transformation of the L shape for which Q is invariant. So Q is not changing. It could be rotating, okay? It could be reflecting in that line, or it could be reflecting in that line, or you can making it bigger from that point here, Q. So Q can be invariant there. Okay. The line joining PQ becomes horizontal, so that line has to go there. So we're looking to rotate it. The area of the L shape does not change, so we're not looking to make it any different. Okay, so there's a two-way I can do that. That line becomes there, and the Q would be invariant if you rotate it, this shape, 90-degree clockwise. Okay, the area will remain exactly the same, and that line becomes horizontal. Another way you can do it is reflecting that line. So that line goes there, that PQ will be there. Okay, so there's 2 different ways you can do that. So I'm going to write one of those saying, okay, well, I like to write it down as a rotation. Rotate that shape by 90-degree clockwise. About, now I need to give it the center of rotation. So center of rotation doesn't change at all basically. The center of rotation is point Q, which is about 1, 1. That should do the job. That's it. So if you like the video and if you found it helpful, please give it a like so everyone else can find it, okay? Because the YouTube algorithm works in a way so more the people like the video, they get pass it on to more people, okay? They find this video useful, and that will probably help me out as well in trying to reach as many people as I can, okay? So like it and share it with your friend if you think they'll probably find it useful as well, okay? Thank you for watching, and I'll see you in the next video.